Good day, everyone, and we are back again. I know that you've been working hard on that physics, and you've probably, aced that exam. And we're still continuing to prepare for, the chemistry exam. So what I thought today was just to look at electrochemistry, just a couple of examples. And I'm going to take this from the 2018 June exam. So yeah, if you haven't subscribed, please just make sure that you are part of the family and you subscribe to our channel. And by the way, just hit that thumbs up if you like the lessons, and some of you have been giving us really good reviews. Please continue doing so. And by the way, for those of you that need help with maths or physics, please just make sure that you get in contact with us, and the email address is info@mlungisinkosi.co.za. That's info@mlungisinkosi.co.za. And we'd be more than glad to help you either in physical science or mathematics. Okay, right, now let's get into the lesson. Okay, so I took this question, as I said, from the DBE exam, May June. Okay, that's the senior certificate, but nonetheless it's CAP, so it's going to actually help us to understand electrochemistry. Now they say to us, consider the electrochemical cell represented by the cell notation below, where X is an unknown metal. So what they've actually given us there is what we call the cell notation, right? Now remember that the cell notation is quite standard, okay, and essentially you always have the anode on the left hand side. So this tells us that this Fe2 plus Fe3 plus, okay, is our anode, and X would therefore become our cathode. Now please note, because Fe2 plus changing to Fe3 plus, can you see it's both in aqueous form? So that's why you don't have that backslash there. In this case you actually have a comma instead, right? So the reason for that is that it does not change in phase, so as a result it's going to remain exactly as it is. All right, so in this case we indicate that by comma. Now of course you've got platinum there that is helping us for electrical contact. So ladies and gents, I don't want you to confuse this with the platinum half cell. That platinum is just helping us to establish electrical connectivity. Okay, so in this case please just make sure that when you see that there, it's actually not part of the, it's not taking part in the reaction. Okay, right, now they said the cell potential for the cell was found to be 0.03. Right, now the first thing that they ask us is to write down the type of electrochemical cell illustrated above. So remember, this would be the galvanic cell. Okay, so to answer that 8.1.1, we would say this would be the galvanic cell. Okay, by the way, you can also call it the voltaic cell. Okay, so in this case, yeah, that is how the cookie crumbles, right? They say, what does this single line, okay, in the above cell notation represent? So it represents, ladies and gents, a change in phase. Okay, so that's 8.1.2. So it represents a change in phase. So look at this. So on your cathode side, you've got X plus changing from aqueous form to solid form. So there's a change in phase there. However, this one remains from aqueous to aqueous, so there's no change in phase, and that's why we're not going to put that single line there. So that represents a change in phase. Okay, and the next question. All right, they ask us, I hope that you can see that well. Okay, so the next one, the next question, they say write down the half reaction that takes place that takes place at the anode of the cell. Now usually what I prefer to do is to actually just try to write down what the cathode half reaction is, the anode half reaction, and find the what we call the net cell reaction at the end before I start answering the question. That would be my approach usually. Okay, but I've already started, so might as well just take it, just wing it. Right, so they say write down the half reaction that takes place at the anode in the above cell. Okay, so which one is our anode? Remember, our anode is this half reaction here. Now we're going to take our standard potential table. Okay, that's exactly what I'm going to do just now, and we need to identify a half reaction that shows us Fe2 plus, okay, and Fe3 plus. So let's do that. Okay, can you see this one says Fe3 plus to Fe? So that's not the one that we're looking for, right? And this one says Fe2 plus going to Fe0. Okay, so that's not the one that we're looking for. So I'm trying to show you that you must actually look for the relevant one. So both ions must actually be represented in your reaction. Okay, so if you look down below there, can you see this one says Fe3 plus to Fe2 plus? It looks like it's the one that we want, isn't it? Okay, but just remember, so it means because it's the anode, right, we're going to write this reaction the other way around, and you can see there it's Fe2 plus changing to Fe3 plus. Sorry if you can't see that properly, but nonetheless, so in this case I'm going to copy that down. Okay, so it means that I'm going to take that half reaction that we got over there. Okay, all right, so this one over there, and I'm going to write it the other way around. Remember, it's undergoing oxidation, it's losing electrons, so it's Fe2 plus undergoing a loss in electrons and becoming Fe3 plus by giving away 1 electron, and the cell potential is 0.77, right? So they said write down the anode half reaction. So in this case it's going to be, okay, we said it's Fe2 plus. Okay, now please note you have to write it down with 1 arrow, okay, to show which reaction is actually taking place. So this is Fe2 plus becoming Fe3 plus, that's ion 3 plus, by giving away 1 electron. So that's the half reaction that takes place at the anode. Now they say to us identify with the aid of a calculation, okay, identify X, that is. So in this case I'm just simply going to use my cell, my E cell, right? So this is equal to the potential of the cathode, okay, minus the E naught of the cathode of the anode, sorry. Okay, so by the way, that reaction or that equation you are actually given in your data sheet, right? So in this case it's just simple. All right, just go to your data sheet. It's this reaction, it's this equation over there. All right, so we've already established which one is our cathode. It must be metal X, okay? But they've also told us that the cell is 0.03, okay? Our cathode, that's what we are looking for. So this is the potential of the cathode, okay? And our anode, remember, that was the Fe2, Fe3 plus cell, and we found that the value there was 0.77. Okay, I'm just trying to show you again. Okay, so there's that Fe3 plus, Fe2 plus, so that value there is 0.77. So in this case, that's minus 0.77. Okay, so now we're looking for the potential of the cathode. So in this case, I'm just simply going to say E cathode. So if I take this to the other side, okay, so that's going to be 0.03 plus 0.77, okay? So and I get a value of 0.80 volts. Okay, so and by the way, that's a positive value. So all I need to do now is go to my table and identify, okay, which one. And by the way, remember, it's aqueous to metal. Okay, that solid form there. So 0.80, you go to your table, and 0.80, there it is there. Okay, and we see that it is silver. So it means that metal X is therefore the silver metal. So that's going to be Ag. And it also makes sense that, remember, the silver has got an oxidation, the oxidation state is 1+ there. So in this case, it makes sense that it should be silver. Right, now the next question, they say the Fe3+, okay, that half reaction of iron 2+ and iron 3+ half cell is connected to copper. So now they take something else, right? Okay, so what I'm simply going to do there is, let me show you how I was going to approach this. So I write it. I said to you, okay, if you haven't watched our video on the galvanic cell, please just have a look at that so that you can see what I do there. So in this case, I'm going to just take the half cells as they are, as they appear, right? So remember, for this one, okay, it's going to be Fe3+ an electron. So I'm just going to copy it down as it appears. Fe3+ an electron, okay, Fe2+, so I'm copying it down as it is. So that's 0.77 volts. And then I take copper, it's copper 2+. Now note, it's copper to copper 2+. So you must make sure that you pick the right one. So that's copper 2+ plus 2 electrons, and that would give me copper, right? And that gives me 0.34 volts. Now, note what I just simply did was just to copy it as it is, right? As it appears. All right, so I'm just going to do some gymnastics over there. Right, we're going to come back to the question. So I just want to show you how I would go about, identifying which one is the anode and which one is the cathode, right? So I said that all you simply do is just to draw the number line, right? And remember, in your number line, you always start with the smaller value to the larger value, so they go in ascending order. So in this case, I'm going to say this is 0.34, and that's going to be 0.77 over there, right? And okay, and I did say that I'm going to sound a little bit controversial. Okay, please, I don't have any political affiliation. All I just try to do is just to make things simpler for you to remember. So you just ask yourself, if you're in South Africa, we say, well, which party is in government? We say, well, it's the ANC, right? So this is the ANC, and we said, well, this only happens one place in the world. Okay, and what is the ANC famous for? It gives away houses. Okay, so just think about that from A to C. Okay, so electrons are flowing from A to C there. So what does that tell you? It tells you that, in fact, that 0.34 belongs to copper. So it means that copper, in this case, would be your anode. And therefore, it means that the iron half cell would now be your cathode, right? So all that you simply remember, ladies and gents, is that now to get the actual reaction that occurs at the anode and at the cathode, all I simply do is I always take the anode half reaction and I write it the other way around. So it means that, remember, which one is our anode? It's going to be copper. So I'm going to actually write it the other way around. Okay, there it was there. So I'm going to actually just turn it around. So it's going to be copper, right? Changing into copper 2+. And what does it do? It gives away 2 electrons in the process, right? So that's anode. It undergoes oxidation, gives away electrons, and then what happens? So the cathode half reaction, I just keep exactly as it is. The only difference now is that I'm going to actually write down with only one arrow, right? So this is Fe2 plus. Okay. Now let's write down the net cell reaction. So when you get to this point, just please always remember that what you need to do first is make sure that the number of electrons is balanced, right? So look at this. We've got 2 electrons that are given, but there's only one that's received there. So what we're going to do is we need to make sure that the number of electrons are exactly the same. So what do we need to do to this one? So we just need to multiply this by 2 so that we make electrons there too. And by the way, you need to multiply everything. So I'm going to multiply this equation by 2. So in this case, it's going to be 2 Fe2 plus. It's going to be 2 electrons, and it's going to become 2 Fe2 plus. Okay, so electrons are equal. So number of electrons given is equal to number of electrons received. And all I simply do, write everything that's on the left hand side of each equation. So that's copper, okay, plus 2 Fe2 plus, which will give me, now everything on the right hand side, it's going to be copper 2 plus 2 Fe2 plus. Okay, right, and you can see how easy it is to really get that in terms of electrochemistry. Now, I think we are almost ready to answer the questions that they asked us. Okay, so the last portion of the questions that were asked, they say to us, all right, so write down the chemical symbol of the electrode in the cathode half cell. Okay, so in this case, which one was our cathode? Okay, we said 0.77, and they said write down the symbol, okay, of the electrode, okay, in the cathode half cell. So in this case, remember that in the cathode half cell, we said our cathode is what? It's going to be that Fe3, Fe2 plus cell. But what do we use as a cathode there, right? If you remember from the previous, or in fact, they even wrote it there, right? What do we use as the cathode? We use platinum, all right, so that it is able to conduct electrons. So in this case, we are going to say that is PT, that's platinum. So this is answering 8.2.1, okay? Sorry about that. Okay, so in this case, we just simply say it's going to be platinum. Okay, you can write there solid if you want to. And then the next question, they say name the oxidizing agent. Now please, I want you to remember, ladies and gents, once we start talking about the oxidizing agent, remember that the oxidizing agent is the substance that undergoes reduction. In a sense, you think of it, the moment you add the word agent, all right, it kind of works the other way around. Okay, so the oxidizing agent is the one that undergoes reduction. Okay, so which one undergoes reduction? Remember, we say that reduction occurs at the cathode. You remember that red cat and an ox thing, right? So anode undergoes oxidation, cathode undergoes reduction. So in this case, to answer which one is our oxidizing agent, which one underwent reduction, which one underwent the gain of electrons? Of course, it's going to be Fe2 plus, isn't it? Okay, so in this case, they said write down the name, so it's going to be iron. Okay, so all right, so that's the iron 2 iron. Okay, So in this case, we know that it's the ion 2+ ion. So that's the one that that's 3+. So that's going to be ion 3, because remember, it's the 3+ ion that underwent reduction. So it is the oxidizing agent. Okay. And then finally, they say to you, and that's what helps with writing this down, because now you can answer all the questions with ease. And it says write down the overall balanced cell reaction that takes place for this cell. And guess what? We've already done that. Okay, so once you go through this process, it really makes it easy for you to now answer all the other questions that follow, right? So in this case, what is our in fact, I don't even need to write that down. You just copy that exactly as it is. And the reason why they also mention it's balanced, because we had to go through that process where we make sure it's copper to 2 Fe2 plus Fe3 plus. Sorry about that. Okay, so that's Fe3 plus, which will give us copper 2 plus and plus 2 Fe3 plus. All right, so you can write that there. And that is your net cell reaction. Just for interest's sake, if they said to you write down the anode half reaction, which one would I write? Of course, this would be the one, right? And make sure just with one arrow, copper to copper 2 plus with one arrow. Remember, the moment you write the double arrows, it means you're not sure which reaction is going to take place. But now we are absolutely sure copper is going to become oxidized and change into aqueous form, and in this case you're going to now have that as your anode half reaction. Okay, and obviously the cathode half reaction. Okay, and by the way, you can now write down the net cell reaction. Okay, right. I hope that has been helpful. All right, you can really score some easy marks when it comes to electrochemistry. Okay, and please make sure, please don't disappoint, okay, when it comes to that. Okay, thank you so much, and I hope that you will still continue to work hard. Please don't forget to subscribe for those of you that haven't, and I'll see you guys next time. Sharp sharp.